So let's talk about a plan. A plan so big, so ambitious, it feels like it's straight out of a sci-fi novel. We're talking about building AI compute on a scale that could totally redefine our future, not just here on Earth, but out in space too. And that's really the heart of it, isn't it? This isn't just some tech upgrade, building faster computers. No, this is about taking all those incredible, epic futures we've read about, the ones from our favorite sci-fi books, and actually starting to build the foundation to make them real. Okay, so here's how we're going to break it all down. First, we'll look at the grand vision, this cosmic ambition. Then we'll pinpoint the huge bottleneck holding us back here on Earth. After that, we'll dive into the solution from Tesla, SpaceX, and XAI. And finally, we'll see how all of this could lead us down a path to some serious abundance. All right, first up, to really get what's going on here, we've got to think way, way bigger. I'm not talking about quarterly reports or yearly goals. I mean, how do you even measure a civilization's progress on a cosmic scale? What does it even mean for a species like us to level up? Well, there's actually a scale for this called the Kardashev scale. The basic idea is that a Type 1 civilization can use all the energy available on its home planet. But the ambition we're talking about today, it goes way beyond that. And if you want to go beyond Type 1, you have to start looking for energy somewhere other than Earth. And that right there brings us to the fundamental problem, our biggest bottleneck. Earth, it's just this tiny dust mote in a vast darkness, right? When your goal is to build a future that's truly epic, the hard limits, the physical space, and the energy we can generate on this one little planet, well, they become a huge, huge problem. Okay, now look at this chart. This really puts things in perspective. You see that breakdown? The sun isn't just the biggest thing in our solar system. For all practical purposes, it pretty much is the solar system. Everything else is just a rounding error. It's the ultimate power plant, and we're tapping into, none of its potential. And this number, it's just mind-blowing. 1/1,000,000,000th. Think about that. Every single power plant, every grid, all the electricity our entire civilization produces, it's just a tiny, tiny, tiny fraction of what the sun cranks out every single second. It's wild. Even if we scaled up 1,000,000 times, we'd still only be using 1/1,000,000th of the sun's total power. So the takeaway here is pretty simple, right? If we actually want to keep growing, if we want to build that future of abundance, we have to go where the power is. And it's not here. The next big step for civilization isn't on Earth's surface. It's got to be in space. There's really no other way. Okay, so how do you even begin to tackle a problem this huge? You can't, not with one company, not with one piece of tech. It takes a really specific, really powerful mix of skills. And that is where this particular trio of companies comes into the picture. It's kind of like a three-legged stool. You need all three legs or the whole thing falls over. You've got Tesla with their incredible experience in robotics and just massive scale manufacturing. Then you have XAI bringing the brains, the AI intelligence, and the know-how to build these giant compute clusters. And then there's SpaceX, who holds the key to, actually getting all this stuff to space. And this is why Starship is absolutely the critical piece of this whole puzzle. Think about it. You can't build giant factories in orbit if it costs a fortune to launch every single nut and bolt. It's a non-starter. Starship is the machine designed to crack that problem wide open, to make getting to space so cheap and routine that a project this massive becomes possible. All right, let's recap. We've got the power source, the sun. We've got the ride to get there, Starship. So what's the missing ingredient? It's the compute, the raw, massive amount of AI intelligence you'd need to manage a system like this. And that is where the Terafab comes in. Whoa. Okay, this chart really shows you the scale of the challenge. Right now, if you took every single chip factory on Earth and added up their AI compute output for a year, you'd get about 20 gigawatts. The goal for this one terafab, 1 terawatt, that's 1,000 gigawatts. A 50 times increase over what the entire planet is doing right now. Just wow. Or think about it like this. The entire global supply chain for chips, going full throttle, can only produce 2% of the compute needed for this vision. 2%. So you can't just, order more. It's not possible. You have to build a whole new way of doing things from the ground up. So what's the Terafab's secret sauce? How is it so different? It's all about speed. speed of innovation. By putting everything, designing the chip, making the chip, and testing the chip all in the same building, you create this crazy, fast, recursive loop. You can iterate and improve at a pace that's maybe 10 times faster than anyone else on the planet. And it's not just going to be cranking out one kind of chip. The plan is really two-pronged. On one hand, you'll have these super efficient chips designed for Earth, for the billions of Optimus robots and millions of cars. But on the other hand, you'll have a totally different beast. High-powered chips specifically designed to survive and thrive in the brutal environment of space, with all its radiation and intense energy.
Okay, let's bring this home. We've talked about the how, but now for the really big question, the why. We've established that we can build all this AI compute in space, but why is that the goal? What makes space the ultimate place for the future of AI?
Well, when you put them side by side, it's a stark difference. On Earth, trying to scale up power gets harder and harder. You run out of land, you've got to deal with clouds, rain, and the fact that it's dark half the time. But in space, it's the complete opposite. It's always sunny. You get 5 times more power from the same solar panel. And the bigger you build, the easier and more economical it gets.
And that's really the heart of it. As soon as you can get the launch costs down with something like Starship, the advantages of being in space are so massive it becomes, well, a total no-brainer. It's not just a cool idea anymore, it's the obvious, most logical path forward.
But, okay, let's say you do it. You build the Terafab. What then? You can't think of a project this huge as the finish line. Nope, it's just a stepping stone. So what comes next? The answer? You go 1,000 times bigger again. You go for a petawatt. And how do you do that? You build your industrial base on the moon. The gravity is so low there, you don't even need rockets anymore. You could use something like an electromagnetic mass driver to just fling materials right into space. So what happens when you combine a petawatt of AI compute with basically limitless energy and an army of robots? You unlock a future of actual, genuine abundance, a post-scarcity world. We're talking an economy that isn't just a little bigger, it could be 1,000,000 times larger than Earth's is today. A world where the whole idea of not having enough might just disappear. And that right there is the ultimate promise. A future where, if you can think of it, you can have it. A world where AI and robotics can meet basically any need you can imagine. It is a radical, radical vision, turning science fiction into science fact. And it leaves you with a pretty wild thought to chew on, doesn't it? In a world with no limits, what would you build?